Happy morning, guys. So this is a continuation of the animations, especially bouncing ball. We'll do the bouncing ball again, but with a different approach. See, normally the ball will bounce from here and it will hit here, then hit, finally it will stop here, isn't it? So you can see the height and width of the bounce is gradually will decrease. So we are going to take the extremes from that. The extreme A, where from the ball is going to drop. It's the first frame. I'm sorry, guys. That key. And then last frame where the ball is going to end the energy. So you can see when you play, you can see that ball is moving left, right. But when it is start, it's slow. Then it ends, it's slow. The interpolation is the matter. So to adjust the interpolation, you need to go to the graph editor, track view, curve editor. This one, what we need is this particular tangents should be a linear, then the last tangent should be the linear. So the energy transform equally from the beginning to the end. The speed is equal. Now we'll fix the bounce. So, for example, if it is bounce here, then it will go back from here to here, isn't it? Then from here, it will go jump, then it will go back here. So that's what's going to be happen. So it's going to jump on a 10th frame, it's a hit the ground, and 28th frame is coming back to the top. Treat. Only the top portion. Then it's hit over here, then it'll come back. Now the frame is decreased. Okay. Now it hit here, then it come back to the position over here. Okay. And hit and come back. Hit and come back. You can see that gradually the distance is decreased. Isn't it? Now you play in between. It has to go and hit here. Now, when you keep it, okay, you can see that hit and go back again, then hit, go back again, and hit. It has to equal to between this and this. Okay. Two more. One. Now we'll check how it looks like. From here, play. Okay, it is jumps like a dolphin. You can see that it's not hit on the ground. As we discussed before, the particular axis, this all should be a linear tangent, right? It's a linear tangent. Now, What about this? This is also linear touch. It's hit on the ground. When you select this, it will show you the value of it on frame. You can see that this is the 30th frame and this is the value. And the frame number and the value. So when we are moving towards down, sometimes we move 26.64, sometimes we move 26.52, sometimes it's different. So we need to make sure that everything is settled in the same value. So copy the value first, select everything, then better you paste the value. Now, the same value, whatever you select, all the ground level, this is the top level now, all the ground level, it has to be in the same value. You can see that. Okay, now what about the top? Here, you can see the curve slow in, slow out. This is sometimes we need to work manually. You can see that I'm scaling this because it is sustaining the, make sure linear. And the key, you can see that bias towards right side. Okay, now the key is straight. So zoom in. Okay. This is the arc should be very good. Need to maintain the arc. This is one of the principal arc. Now we'll check. Can you feel the weight? Okay, guys. So this is an idea of the real bouncing ball. You can create the weight by using this particular area and how much it has to sustain in the air. The ping pong ball is jump different, the iron ball will jump different. But do the bouncing ball first. We'll see the difference between the weight of the ball later. Any question, please let me know. And this is your assignment, a bouncing ball, a proper bouncing ball. Any questions, guys? Any questions? In this one, the timing may vary. Example, when you're playing, you can see the time, isn't it? It's not a 24 frame per second, 25 frame per second because it's the oscillated frames. Because the cache memory will defer your animation. It's not the exact real-time animation. So you need to grab this one as a video file. To do that file, and then our tools, you can see that grab viewport. You have to do that, create preview animation. It is very much helpful for you to, so you can see that what is the playback frame. So 25. Okay, 1 to 100 frames. Geometry you need to catch. Nothing else. Just click create. It will save on this particular create. Once you click, it will capture the frame by frame and it will turn into a video file. What is the different? The difference is when you play inside of 3ds Max, you can see the pose, of course, you can see the animation. But the real-time animation, you have to grab this. It has to come as a video file. And then you can see the real-time animation. Few more frames. in the media player. You can see the media player now. Yes. Now we'll see the animation. You can see more smoother in real time. Okay, guys, that's it today's section. Please do it and send it. Thank you, guys. Have a very good day.